Hello all, this is the second video of the BSL and BST tabs. We're going to be going over the filter function of the weight of the lights according to this. And we're also going to be going down through the DDLs, adjusting percentages and doing a manual optimization for the cap rail. As always, please watch the Anatomy of CRL series for a general overview of CRL sheet shared functions. Coming up to the top, I have here values that are just a standard courtyard. This is the east. It's one run at 1200 inches. We have a height of 96, which is where this should be on laminated. You're going to need a rather thick light of glass as opposed to BST, which is basically just for pool enclosures or balconies or just decorative railings, you know, on the hardscape outside of a building. The weight filter only goes less than 150 or greater than 150, excuse me. Coming back to BSL, I sold a job that had 114 heights and we used 17/16, the thickest. And we also had a cap rail because it keeps the rail more in line. Just to demonstrate how this works, we have a glass pounds per square feet according to your drop down. If you go 9/16, that'll adjust the pounds of each according to the individual square footage drawn from the width and the height. That then filters over here into the appropriate box. And finally here where you can apply a separate number of men for install. 50 is the total number of lights. All right. So let's bring it up to 17/16 and go 114. That brings them all up to above 450. At which point you might want to go, 30, Marty. We'll go 7. That one's nuts. 2 at 26, I don't know. Anyway, that moved it down nicely. So that's just the way you do that functionality. Coming down to the CRL parts here, a good amount of the quantities are figured just from the inputs here. And sorry, my dog was barking. So a good amount of the values are already figured just from the inputs, such as taper locks. They are figured with this long formula. It's basically saying if the width is less than 14, you do 1 between 1428.2, 56 to 75, and etc. That is taken right from C.R. Lawrence literature. Let's see here. So the end caps, I go over this often, is just doubling the number of runs. And here is the hardware. Generally, hardware 2 is not applicable. And that is adjusted by this here. I do not recommend using 24 inches. Unless it is signed off by an engineer. Generally, you may want to figure 24 inches on BST. It will save you a lot of labor time, but just be aware that that is potentially a no-no. So let's do an optimization, then I'll just kind of run through them again. So it's best to keep this at 0 when you do the optimization, and I'll show you why in a second. So optimize 10-foot stock lengths. This doesn't have the option of a 20-foot stock length like BST. So that button created the cut sheet. The reason I suggest keeping it at 0 for the cut sheet is to make sure that these are the same. The cut sheet will give you the raw number, and it will not acknowledge the percentage add because it's just pulling from here, right? So this is your raw That would be that right there. The percentage add you can do afterwards. So we do 20%. Now when I hit enter, notice how the cladding will follow the base shoe, right? So one from 23 to 28. That renders this kind of useless because this is a 1-to-1 to here because they're both 120 inches. Well, 118, I guess. So just be aware of that. This is kind of useless, to be honest. So just as long as, you know, the cladding on 120 is 120. If you're using a 240, it'll be double. So if I just do, you know, 2 of these, it'll put 4. And realize that this is interior and out, you know, inside and outside. Moving on here. So because we're on fascia, the 90 and 135 corners are not available. This is a manual fill, meaning that it does not react to this. So generally you're going to want to cut this according to the angle if needed. These are, you know, welded, cladded, expensive. So if you want to put those in, you're more than welcome. They are kind of aligned with the welded end caps, which definitely looks very nice. But don't do it unless specifically requested, because they are much more expensive. The end caps here, the typical end caps, you just screw them in with screws, I believe, depending on the... Yeah, I think you just screw them in. It says CRL on the side. This is simply double 5 and is estimated for review. If you're to adjust it, it will be less. We have drop side and inside vinyl. Okay. They are different. Be aware of that. And you can adjust this. So we're looking at 3 at 100 feet for 16. So if we go to 200 on the fly, it'll adjust it for 19. So it's better to go with 100. I don't see why you would do an increase here. Generally, you're going to want an increase on the hardware. The tapers might get lost in the truck and XYZ. So this is just figured from the inputs from these values here, basically. And we'll go back to 0 just to show you. So we have 204 and 190. So this goes to the next 10 because they're bought in packs of 10. Well, I don't know. I believe some of them are bought in packs of 10. I'll have to check that. Anyway, so your hardware is figured. If you have any input, let me know. I can just copy this and go right to the CRL Lawrence website and see what it actually is. These are your substrate choices. This is taken from CRL Lawrence literature. There's a very nice CAD drawing that they have that show the details of attachment at the base and the details for a cap rail as well. And the cap rails are very different according to the thickness. Be aware of that. This drop down is it's a dependent drop down. DDL is incumbent on standard or fascia. So I'd switch it to fascia, and we have this here. So if I go to standard, it will adjust this to weld block, concrete with drain block, steel. The weld block and I believe concrete with the drain block are the ones that use the secondary hardware. So let's just do that here. Weld block. That'll do 21 of them. Packet of 10. I'm gonna check that. I think maybe the BSTs are a packet of 10. No, that's each. I'm gonna check that out. Installation kit if you want to do it. So let's do a manual optimization for the cap rail. This has a wide range of availability here. So we are on 17/16, which has the least amount of availability for cap rails. So we'll go here 9/16 and show you the full gamut. Extruded radius is aluminum, so it'll return aluminum finishes such as, well, I'll just do it. Let's see here. It is the cheapest. So these are not chosen yet. That's why it says NA. I have to choose one of these. So mill, satin, dark bronze painted. Welded radius. Looks like one is already chosen, 166. These are a a stainless finish. Anyway, so let's just do it. Some of them have a secondary length of 14 feet, and it does vary. That's why I put both of them in. This would have to be a manual. This is a suggested, estimated for review. So let's do a manual. Let's pull these out. And let's figure we'll do 120. So we go over to optimization. 120 is already in there. And paste values. All right. Now, when that goes in, it'll automatically figure for processing and splitting it. So if I make this 168, it'll change it on the fly. Just be aware of that. Because of the macros, you should use these buttons. So you're putting in here, and then you're copying from here. So it's saying copy from IJ to AB. And what that does is cancels this out. The macro screws up when that's not cleared out. So just don't ever copy this manually. Use this button here. So manual optimization, let's do it. We have 23, and we're going to say BSL dash cap. BSL cap. Dash 10. All right. Now we're going to use the GC to move it before BST. There it goes. It's over there next to it. We have here 23. And the program figured 26. So you can manually put that in. And you can adjust this as well. Oh, you know what? It probably was right. Let's do a reset. 21. So it was actually less than what you needed. So what that's doing is taking a direct linear feet and dividing by 120. So that was less. So be aware of that. So let's just redo it again. BSL cap at 23. And let's check this as well. So that's the end caps, and this is 100. So it is 202 rounded up to the next increment of 100, which is 3. You can maybe make this 2 and get away with it. So you still have to put your thinking cap on when you're doing this, but it does make it all nice and easy for you. This gets screwed up sometimes. So there's your CRL. Everything's in there. And that's basically it. I'll print a CRL. And sorry about this. I didn't. These are just some functions in the bottom. There it is. That's how it should look. There it is. Sorry, this is a little bit of a long video. Control 9. I don't know why it took so long, but anyway, there is. Sorry, I'm pushing too many buttons. there is your RFQ. Thank you very much.